Welcome back. My name is Paulaj বিশ্বাস, Assistant Professor, JS College of Engineering, Department of Mechanical Engineering, and also the today discuss about the interference of positions and orientation. And this is the under my subject of computer aided design, and also this is my lecture number 26. And also what is the interference of positions and orientation? This will be first discussed. According to this, the designer and manufacturer should check jointly that they provides product can be assembled without interference between parts before the product to be manufactured. Similarly, all the CAD tools presently have to have the potentials to directly analyze the possibility of a specified assembly plan for a product is considered, and assessments of previous assembly sequence and optimizations research explains that most previous assembly planners apply either the features meeting or the interference free techniques to find assembly parts. Interference interactions will be comes here in both features metric and interference free techniques focus upon the basic geometrical data and restrictions for the design products, which are generally contained in conducted CAD files also. Suppose you are the positioners or interference, this like you concerned according to your the matting condition, that is the different gear as like as your the cam and follower also will be concerned this. The when the complete automates the products of creating a professional assembly plans. The basically the we have to create a automatics, that means that during mattings will be records, that is the automatic assemblies will be given, motions will be found, and by through your the CAD systems. And again different the different force closures pairs also will be available, that is or the already read out the kinematics and dynamics of machines papers. That means your the assembly plans geometrical informations for CAD methods should be automatically taken from CAD files, analyzed for interference relationships between the components in the assembly, and then design for utilized the assembly analysis tools will be concentrated here. Suppose you're the CAD 3D models you have to concern. That means you're the different compiler we can this, and also the your assemble, that like your the interference will be movement properly, that like the how you will be created the automatic automatics mattings are the this will be disassembled also will be the automatically the which parts will be separated from the we can see that like your the 3D animations figure. And uh, the most of the previous assembly sequence planners do not have the potentials to complete the three tasks. They need user to manually input part attributes or interface data, which is so time consuming factor is come. The determining interference relationships between parts is concerned. In automated assembly schemes, most parts are assembled along with the principal axis is comes. Hence, to find interference between parts while assembly, the project techniques reference refer the six assembly directions along with the principal assembly axis. That like your the we can concern according to the degree of freedom. Similarly, the during to the which axis you have to maintain according to your the project, that like you have to concern the assembly of this the different components, and which direction this will be movement will be considered. Then this is the project techniques refer the six assembly directions along with the principal assembly axis, that like your the plus x axis, minus x axis, plus z axis, plus y axis, plus y axis, minus y axis, and plus z axis, and plus minus z axis. But the method could be improved. This method could be improved to think other assembly directions are as required. That means you are the other assembly directions as required. The projected sim systems use the projections a part coordinates onto the plans in three principal axes, that is the x, y, and z axis, to find that the observe obstructions between the part slidings along sum of the 6 principal assembly axes is comes here. That means you have the three directions. That means the 3D x, y, z, and also this is the positive as like as you have the negative. This will be concerned according to what the 6 sliding axis principles, assembly principles will be come here. The projections overlap between any two parts in a specified axis. Directions shown a potential interference between the two parts when one of the two parts slides along the specified directions will be here. The with respect to the others is the concern according to the projects overlap is considered. Suppose you have to concern according to the movements that like your the assembly conditions is found that is the 3 axis, that means you have the 6 axis or the 6 movements, 6 assembly directions movement will be considered. The vertex coordinates for overlapped projections are then evaluated to find if real collisions would happen between parts with the overlapped projections is considered. That means your the vertex. The vertex is movement and like your the coordinates for overlapping to each other. That means your the projections, and it is the evaluated to find if real collisions would happen between the parts with the overlap projections is considered. The planned process storage that determines interference data for allocated assembly directions in a group of interference free matrix will be comes. Suppose you have to given some your matrix and that like your the group interference will be find that like your the similarly to your the group technology you have to putting her the how you have to allocate it and as like as you have the assemble to this the different component at is the sequentially, then this will be concerned according to your the given the data is allocations is here, and comparatively with previous planners of assemblies come here. The swept volume interference and the multiple interference direction systems are appropriate for three-dimensional interference determinations between the boundary representations entities. That means you have to given your the boundary entities. Either it cannot be properly the interference that like you have to given your the data is the assembly is the proper way. That means your the different component is the given as assembly is like as, and you have to given your the boundary representation. That means your the BF, this will be required for the interference determinations, and also this will be required for your the three dimensions interference determinations between the boundary representation entities. Both techniques are developed for real-time interference detections between two moving parts in a simulations environment. That likes the as a result, those two techniques are expensive in computationally. And another thing is that for the assembly planning issues, actual collisions finding capacity along subjective relative motions vector is not required. That means you can find the assembly planning issues, that is the actual collisions. This will be finding this capacity along the subject relative motions. Vector is not required. And another thing is that means that instead a efficient the computational technique is required for finding if two parts the will collide when they are assembled in a specified order along any one of the 6 principal assembly axes. That means your the 6 principal assembly axis is considered, that is the X, Y, Z, positive and negative directions will be concerned according to your the assembly direction. That means that you have to assemble the different components on your the base principle, that like your the base components, and one by one you have to assemble on your systems during your the 6 assembly axis. The interference free matrix. An interference free matrix shows interference between two components when one component is moved in a given assembly directions into an assembly locations with another component already in a and assembled locations. Suppose the you have to concern according to your the two components, and the two components is required to assemble. That means your the one component is assembled required to your the which directions will be movements, and the another components already the put up on your the assemble position. That means already an assemble that like your the locations. Either you cannot be starting for the assemble during to your the on by on, and because the each and every components you have to requires to assemble the one by ones. That means the assembly actions that results in interface are denoted as, that is the zero in the matrix, and the assembly actions that do not result in interference are denoted as on in the matrix will be considered. Basically, we can say the this type of on figures will be considered according to your the three components will be given. That is the parts on, part 2 and also the part 3. And you can see the suppose you have to first starts on this your the component on the part on. That means your the part on is be placed according to your the assembly locations, and again your the part 2 this will be connected to this. That means your the assemble to this your the part 2, the part on, and also the part 1 and part 2 will be required to the assembly. That is the one is the placed on your the desired locations. That means your the second parts will be required to movement to assemble to this the parts on. Similarly, the part 1 and 2 will is the complete your this the movements. That means your the assembly is the full completed. Then you have to concern according to your the third components. That means the part 3, and this part 3 also will be required to the assemble on this the part 1 and 2, and you have to give it to your the complete figure. That means your the interface of this the three parts, and you can see that means the part 3 also will be required to movement to directions, and also the required to assemble of this the exactly positions will be here. You can see that is the interface phase free matrix of an assembly having the three parts for assembly movement slidings for infinity of negative towards infinity of positives along the x direction as in the follows. That means you have to consider according to your the infinities movements will be consideration that like as your the parts 1, 2 and 3. That is the movement, the infinity of your the positive movements. That means your the infinity of your the negative movements also will be considered according to your the movement. That like your the interference of these three components of component. That means you have to use for the assembly conditions. The interface free matrix for sliding in the plus x directions will be concerned. That means the parts 1, 2, 3, and this is the horizontal as like as will be considered as the verticals, and the three square matrix you can see. That is the first as row we can first as column we can write it, that is the 0 0 0, and the second column is considered is the on 0 1, and the third column is find here, that is the on 0. The row in the interference free matrix indicates the components being shifted during a given assembly operations, and column indicates the parts that have previously been assembled is here. The suppose you have to concern according to your the different components, that means your the operations, and column that likes you have to indicate the parts that have previously been assembled, and you can do see this is like a figure that like you have to assemble of this the interference of this the three parts. You can see hence the since matrix element, that is the 2 on is equal to 0, that is the if part 1 is assembled initially, and after that part 2 assemble in the direction of x positive x, part 2 will collide with the part 1. That means your the part 2 is the collide with this the part 1. That means you have to concern the part 1 assembled initially, and after that part 2 is the assembled in the direction of x positive x, and the part 2 will the collide with the part 1. You can see this figure. That means you have to concern the part 1, 2 and 3. Similarly the matrix element 1 2 is equal to 1, that is the if part 2 is assembled initially, and then part 1 is assembled in the directions of plus x. Part 1 will not collide with the part 2. That means your part 1 not will be collide with this the part 2. And similarly, as a part cannot be assembled after itself, all elements in the diagonal matrix are set to 0. That means the diagonal matrix you have to consider, that means the set to 0. As a whole, 6 matrices are utilized to show interference relationships between part in the 6 principal axis is comes. That like the 6 principal axis you have to previously discuss. That means the positive x, positive y, and positive z. This will be the 3 axis. That like the negative x, y, z also will be concerned the another 3 axis. That means the concern the 6 matrix. That like the 6 axis will be concerned to show the interference relationship between parts in the 6 principal axis will be here. When the robotically creating the interference free matrix, the projected algorithm find matrix elements row by row. That means that likes you have to concern the robotically creating interference free matrix is here. That is the find for the algorithm matrix elements that is considered according to the row by row. And another thing is that when the two parts would interference through assembly in a given directions, that means the program inserted a 0 in the corresponding matrix positions will be considered or inserts as a 1. Basically, you have to given that like the parts would be interference through the assembly in a given directions. The program inserts, that means the 0, that is the corresponding matrix will be considered. The another concentrations will be given, that is the geometric tolerance. This will be the geometric tolerance. The function of geometric tolerance is to explain the engineering object of components and assemblies. The datum reference frame can explain how the parts, that means what is the tolerance and what is the given this tolerance of this here, and basically you have to given some the during the assembly conditions of this the object, that like the components you have to given some tolerance, either it cannot be assembled the properly, that means the datum reference from can explain how the parts, and tolerance can accurately define the dimensional needs for a parts, permitting over 50% more tolerance than coordinates dimensionings in a few cases you can see. That means the 50% more tolerance, that means the coordinate dimension is basically the tolerance is be considered, that will be the few movement of here. Suppose you have to fit a shaft and fit a nut and bolts, as like as the nut will be movement through the bolt, and then you have to give a knot the any kinds of tolerance, then your nuts is the knot through the movement, that makes this will be on whole is the concentrates during to the bolt, and also the nut will be goes through the inside, and either you have to given some tolerance, that is the possible, either it cannot be fitted to each other. Similarly, the tolerance can accurately define the dimensional needs for a part, that means the permitting over the 50% more tolerance than the coordinate dimensions in the few cases we can see. Suppose we cannot be given this the proper tolerance, that like the 50% more tolerance knots will be given on the component will be the assembly or the fittings, then this will be difficulties will be arise. Suitable purpose of tolerance will confirm that the part described on the drawing has the preferred forms, fit and purpose with the highest possible tolerance will be here. Basically, the different type of tolerance will be given. We can know that is the shaft-based systems, as like as the hole-based systems will be considered. Suppose the geometric tolerance you have to given is here. That's mean the different dimensions figure you have to concern. That is your the you have to give in figures. That is the concept is here. That is the A B C is concentrates according to your these figures. The A is concerned according to this will be a movement. That is the suppose the A is A is the diametric shafts will be here, and during to your the diametric shafts you have to concern that like your the tolerance is the 0.20, and also the this 0.20 this will be matting is the help to the mat to each other. Either it cannot be required to, cannot be complete your the matting, either your the geometric tolerance also will be concerned. And also the B and C just like as will be concerned according to your the dimension, and you have to give in to your the diametric figures you can see. And also the B and C you can see that like your the B is be given, that is the negative value is the 0.375, and also the C is given that like your here C value is also will be given 0.20 is the concern according to this, that is the negative value will be found here. And you have to concern according to here the two positive the distance you have to 0.5 0.5, and the uppermost portion you have to concern, that means your the 1.630, that will be the tolerance will be given, that makes that likes your the uppermost portions. And another things will be here, that like your the A is the negative and positives will be given, that is the that is the 0.293 will be concerned according to your the A. And another things is concerned that will be find is here, that is a 4 into the diameter, that is that 4 into diameters will be considered, that is the some 0.219 plus minus 0.005, just like you will be given, that is the your geometric tolerance is the considered according to here that likes your the port size. This is your the basically this will be this shafts also will be the diametric shafts will be concerned. And then this type of movements and also this type of tolerance also will be records. Either it cannot be fit properly, that like your the assembly times it will be not properly assembles of here. And another things is seen, that is the on hole you can consider according to the point 0 0.5 to on this will be concerned according to here. And another will be concerned calculates your the 0.5 to 1.090 is another is here, that is the 1.250 will is concerned according to this. And this will be is concentrates according to the geometric tolerance is here. And the fundamental rules for geometric tolerance, basically all dimensions should have a tolerance. That means your the all dimensions either you cannot be fit properly, and although it cannot be assembled properly, or pure different components. For this will be required for the all dimensions should have a tolerance. Its attributes on every manufactured components is subject to change. Hence, the limits of acceptable difference must be defined. That means your the different components, and each components will be considered as the limits of acceptable difference must be defined is here. The plus and minus tolerance may be used for two dimensions from a common tolerance blocks. That means you have to given, that is the positive and negative. You can see that is the previous figures will be concerned, that is the positive, and like as your the negative is given, that is the common tolerance blocks will be concerned. And another thing is that is your the dimensions describe the geometry and allowable change. That is your the dimension. This will be describes the properly as like as your the geometry and the allowable changes. Measurement and scaling of the drawing is not permitted excluding in certain case. That likes your the dimensions, that is your the geometry, that this will be measured, and like as your the scaling of the drawing is not permitted excluding in certain case. Engineering drawing describes the necessities of complete parts. That means the CAD systems you have to concern the first will be through 2D we have to draw, and again this will be converted to the 3D modelings. That like you have the different components will be necessitated the complete parts, and another things the is dimensions and tolerance needed to define the complete part should shall be shown on the drawings. And another cases is here, if extra dimensions would be useful, that like sure the extra dimensions would be useful but are not necessary, they may not be may be noted as the reference is considered. That means you are the not necessary and may be not noted as the references is here. And the dimensions should be used to attribute and arrange in such a way as to show the purpose of the features. In additions dimensions should not be subject to more than one explanations is here. Descriptions of manufacturing systems should be avoided. That means your the description as like as your the manufacturing systems should be avoided. The geometry should be explained without defining the technique of manufacture. That means your the geometry should be explained without defining. If some size are needed during the manufacturing but are not wanted in the final geometry, they should be noticeable as non-mandatory. This will be maybe noticeable, maybe not mandatory. You will be concerned according to your the during to your the manufacturing half. That like your the manufacturers will be not wanted the final geometry, that they should be noticeable. And another case is the all dimensionings and tolerance should be placed for utmost reliability and should be used to visible lines in the true portfolio of profiles also will be here. The basically the this will be required that like your the all dimensions and required to your the all tolerance should be placed, and either it cannot be either for the utmost reliability, and basically the you have to given to your the dimensions that like your the tolerance, but this will be not the really ability, then you cannot be put up your dimensions properly. That means you cannot be assemble your the components properly. For this will be should be visible lines in true profiles also will be created. When the geometry is usually restricted by codes, that means your the different codings will be applied, that is will be restricted by the codes. The dimensions shall be integrated with code number in comments below the dimensions is the concern. That means your the not is the proper dimension, this will be the below dimensions. If not openly declared, the all dimensions and tolerance are only suitable when the items is in free. That is will be concerned the only declares the all dimensions and tolerance are only suitable when the item is in free. And another case is dimensions and tolerances indicates to the full length. That means your the dimension as like as your the tolerance indicate to the full length, width and depth is concerned according to this your the different dimension as like as your the tolerance depth. And the tolerance symbols is given. The tolerance symbol for tolerance are bilateral unless otherwise defined. For example, the locations of a hole has a tolerance of 0.020 millimeters. This indicates that the holes can be moved plus minus the 0.010 millimeters, which is an equal bilateral tolerance. It does not considers that the holes can move plus 0.015 or minus 0.05 millimeter, which is equal bilateral tolerance is considered. You can see this will be the different symbols for the geometric tolerance is given here. That is the one is the straight line is given, that is the left, and the flat you have to concern, and round shapes will be given, that is the cylinders, and circuit rounds will be given, that like your the another is the total round runouts, and also the perpendiculars will be given, that like your the here, and also the parallel lines also will be given your the symbols, and also the true positions, that is your the true position symbols will be given, the concentric symbols will be given, the profiles of surfaces is given, that is your the profile of lines you have to concern, and angle, diameters, radius, and minus dot x, and x will be given, that like your the datum, that is the minus, and also here, and during to this type of symbols will be given for your the geometric tolerance. The today discuss that like your the different tolerance systems, that like your the symbol of tolerance, that is when you have to consider your the assembly times. And next, thank you students.